Hi, boys and girls. It's Mrs. Horowitz again. Welcome back. In our lesson today, we're going to keep working on our strategies for finding sums. Do you remember this important word, sum? I hope you do. You've heard it in our last lesson, and you've probably heard it in prior years. It's the answer when you add. And we've been working on adding numbers into the thousands, and we're working on our efficient strategies. Take a minute and pause the video to remind yourself what were the efficient strategies in our last lesson. Are you ready? Me too. I hope you were thinking about decomposing numbers, where we flexibly break numbers apart and put them back together in ways that help us. I hope you were also thinking about adding by place value, putting ones with ones and tens with tens and hundreds with hundreds and thousands with thousands. You might have been thinking about our new vocabulary word, the algorithm. The algorithm also is adding by place value, but remember, when you do an algorithm, you're using place value in a very specific way. You're following a series of steps and using certain rules. We'll talk more about that in this lesson. So let's take a look at this problem of the lesson to get your brain juices all warmed up and going. Take a look at this. What strategies would help you solve? Is this a time when you're going to decompose or use place value? Will the algorithm help you? Yes, I heard lots of kids saying the place value is what they're seeing and they're going to use the algorithm. Lots of kids are saying that they see that 7 ones and 2 ones make 9 ones. When we start an algorithm, we always start in the ones column. And I'm glad to hear many of you are thinking about this. 7 and 2 makes 9. Great. Could we keep going with our algorithm and think about this column? We have 2 tens, which I've already set up for myself over here on the side. If I start with 2 tens, and I'm going to end up with 9 tens, do you know how many tens are going to go with the 2? Oh, I hear some kids who are not sure. Well, if you're not sure, here's a strategy that can help you. You already have the 2, and you're going to keep going until you get to 9. 3, 4, 5, 6, 7, 8, 9. I had 2, and I added something with it, and I ended up with 9. Here's the 2 that I started with. What did I have to add on to the 2? 1, 2, 3, 4, 5, 6, 7. 2 and 7 makes 9. If you already knew that, great job. Thanks for being patient while the kids who weren't sure figured it out. 2 and 7 makes 9. Could you use that same strategy to figure out how many hundreds we need? We're starting with 4, and we're ending up with 8. Yes, lots of kids are using their doubles facts. Great work. 4 and 4 makes 8. So 4 hundreds and another 4 hundreds will give us 8 hundreds. And we see that 4,000, let me get my highlighter back. 4,000 and 2,000 is 6,000. So 4,427 plus 2,472 equals 6,899. I don't know what just happened to my marks there. I was trying to erase these little arrows because it was kind of messy. And my pen went crazy. But now we can read it a little easier. 4,427 plus 2,472 equals 6,899. Let's keep going. Okay, this next question says, what strategies can we use to find the sum of 1,200 and 1,900? And you can see that I've set up some base 10 blocks, the 1,200 on the top and the 1,900 underneath it. Very often we can use base 10 blocks to help us solve. In fact, I'm looking at this set of base 10 blocks here, the 900s, and I'm noticing that it's just like the 10 frames that you've used when you were younger. If I filled in this 100 from the 1200 and I moved it down here, doesn't this look like a full 10 frame? Only this time we have 10 hundreds. What do you know about 10 hundreds? I'm decomposing the 1200 into two parts. Did you see? So one way to think about this problem is to decompose the 1200 and keep 1100 of it together and move the other 100 down here with the 900s. Why does that help me, putting these 10 hundreds together? Do you know anything about 1000? 10 hundreds has a special name, 1000. Well, that sure does make this problem a whole lot easier to solve, because I saw that there were 2000s here, the 1000 from 1100, and the other 1000 from 1900, and this new 1000 that I made with the 10 hundreds. So I've got 3000s right there. If 1000 is 1000, 30 hundreds is 3000. So I've got those 3000s, 10 hundreds here, 10 hundreds here, and 10 hundreds circled here together. And then I've just got this one more 100 left. 3100 is pretty easy to put together. I ended up, well, let me show it to you one more way. So one way that we solve this is by decomposing the 1200 into 1100 and the other 100. I put that 100 with the 900 to make 1000. Another way to think about this problem is to think about the 1200 as all hundreds. There are 12 of these things that we call hundreds. The 00, right, reminds us of hundreds, like 100 is 100. So I've got 12 hundreds in 1200. And I've got 19 hundreds in 1900. Let me erase some of the pictures so that you can see that a little clearer. And I'm going to slide this 100 back where it was. Here we've got 10 hundreds and 2 more hundreds. That's how I got this 1200. Here we've got 10 hundreds and 9 more hundreds. That's how I got 19 hundreds. Do you know 12 and 19? Well, 19 and 10 is 29, and 2 more is 31. So another way to think about 1200 and 1900 is thinking of it as 31 hundreds. And we know that every 10 hundreds is 1000, so 31 hundreds is 3100. We can also use the algorithm to help us solve. We can, oh, that's not what I wanted. We can say that 0 and 0 in the ones column is still 0. And 0 tens and 0 tens is another 0. And my 9 tens and 2 tens, do you remember how many tens this is all together? 10 tens and one more 10, 11 tens. 11 tens has a special name. It's 1000 and 100. 9 plus 2 is 11, which is this 10 and one more, 11 hundreds. But we already said that this 10 hundreds has a special name, 1000, right? So let's write that 1000 a up here with the other thousands? It makes sense. It is 1,000. And there's just this one other 100 that looks like 100. So I'm going to put that 100 here with the hundreds. And now I've got the 1,000 that I grouped and the other 2,000s that were there from the beginning, which is how I get 3,100. All right, here's our big finish. I'm giving you another question with a missing piece. And I'm going to ask you, do you have the same strategies that will help you that you used in the first problem? Can we do it by place value? There's a trick here. Let's give you a minute to solve. Okay, are you ready? Many of you were noticing that there were 8 tens and something with it, but that would only end up with 1 10. That seems impossible, right? I can't have 8 tens, add more with it, and only end up with 1. Lots of kids were realizing that that 8 tens must really go up to something high. It has to go up to something higher because we're doing a sum. Numbers can only go up. So from our 8 tens, we needed to figure out what other number has 1 10. Here's 9 tens, 10 tens, 11 tens. 11 tens has a special name. If I group them with the 10 tens together, that's 100. And one more 10, 110. 8 tens and 3 tens is 11 tens. 11 tens is 100 and 110 here. Do you see the 11? 10 tens and one more. So 8 tens, I needed 3 more tens with it to make 11. And that works out great because you might have noticed that the question originally said 300 and 400 is 800. That's impossible. 3 and 4 is 7, so 300 and 400 is only 700. But now that I regrouped and had these 10 tens making another 100 right here, now I have that extra 100 to make 800. So 5,382 and 2,436 is 7,818. I hope you guys are doing great with your regrouping and thinking about place value. You're going to show off all you know on 2 Google slide pages today. Your teacher will have posted them for you. Good luck, and I'll see you guys next time.